were to look at this problem right here, x squared plus 16 equals 0, and I solved it like we did today. We'll subtract 16 from both sides. X squared equals negative 16. Then, because I have the square, I'm going to get rid of it by taking the square root. Now I have a problem. I can't take the square root of negative 16. Square roots mean something times itself gives me that number. For example, if I look there, the square root of x means x times x. Some number times itself gives me whatever is under there. Because we can't multiply a number times itself and get a negative answer, I have to go about a different way with negatives under my square roots. When we have to take the square root of a negative, there is not a real number to represent the solution. So we use an imaginary number. The square root of negative 1 is I. Commit that to memory. Alright. We know that I is equal to the square root of negative 1. Well, if I looked at I squared, because that would be I to the first, I squared is essentially I times I. Remember, when you multiply them, you add the exponents. That means that I've got square root of negative 1 times the square root of negative 1. Anything times itself in a square root is the same thing. So if I had, for example, the square root of 3 times the square root of 3, you basically just cancel out the square roots and you're left with 3. If I had I to the third, that would be I squared times I. Well, we just figured out that I squared is 1 and I is negative 1. Oh, I'm sorry, this is negative 1. So 1 times I would give me I squared times I. 1 times anything is itself. So 1 times I would be I. So we've got square root of negative 1 is I squared is negative 1. This one, I'm sorry, yeah, I forgot my negatives. I cubed is negative I. Okay? If we go to I to the fourth, that is the same thing as I squared times I squared. And we figured out I squared is negative 1. So negative 1 times negative 1 for I squared and I squared. Negative 1 times negative 1 is a 1. Okay? We keep going. I to the fifth. I can break down I to the fifth as I squared times I cubed. Okay? I squared we figured out was negative 1. I cubed was negative I. Negative 1 times negative I is I. Okay? Keep going. I to the sixth can be I squared times I to the fourth. I squared is negative 1. I to the fourth is 1. Negative 1 times 1 is negative 1. Now, you should start seeing something happening each time. We started out with I, then we went negative 1, negative I, 1. When we got to I to the fifth, we started back over at I. Then we went negative 1. So if we did I to the seventh, which is I cubed times I to the fourth, I cubed was negative I to the fourth was 1. That should give us negative I, which flows with our pattern. Alright, I to the eighth is going to be I to the fourth times I to the fourth, which is 1 times 1, which is just 1. So my pattern is going to start repeating over and over and over. I negative 1, negative I 1. All the way till infinity. Alright, if you look at the bottom of page 9, you've got that chart that we just made. I just wanted to kind of go through and tell you why it is the way it is, but it's the same thing. Alright, on page 10, the first question asks, what pattern do you see? Well, we created a pattern of I, negative 1, negative I, 1. So I1, make the 2 negative in the middle. Alright, what if we were given I to the 65th? We wouldn't want to have to do what we just did, listen out all those ways we can make 65 when adding, all the way that far. That would take forever. So what we can do, because everything repeats after 4, we can use some long division and 4 to see what it should be. So when I use my long division, I am concerned with my remainder. Calculators that we use in class don't really show us a remainder. They show us the decimal. We want the remainder, so we're going to have to do some long division, old-fashioned division. So 4 can go into 6 one time. 4 times 1 is 4, and we're going to subtract. 6 minus 4 is 2, and we're going to bring down the 5. 4 times 6 is 24. Subtract, and we have a remainder of 1. That's what I'm concerned with right there, what my remainder is. So that means when I look at my remainder, I'm going to go up here, I'm going to look at I squared, I cubed, and I fourth. That's going to tell me what my remainder is. So if I have a remainder of 1, I'm going to look here. There's 1. Basically, I'm matching up my remainder to the exponent. So 1 is I equals I. So I to the 65th, simplified, would just be I. Alright, the second one, I to the 244th. Same thing. I'm going to take 244, and I'm going to divide it by 4. Okay, because our pattern repeats, every 4, we want to look at our remainder to see what exponent would be left. So I can't go into 4 can't go into 2, but 4 can go into 24 6 times. So 6 times 4 is 24. Subtract, that leaves me with 0. And I'm going to bring down my 4. 4 times 1 will give me 4. 1 times 4 is 4, which means I don't have a remainder. When I don't have a remainder, my answer is 1. No remainder means 1. Everything worked out evenly. 1 is my answer. Alright, if you look down at the bottom of page 10, we're going to take a step back and visit some stuff from the past couple of years in math. If we were simplifying these radicals, now this is the part where you do not need a calculator out. This is old school handwriting. Alright, if I want to simplify the following radicals, I want to figure out pairs. Okay, going back to prime factorization, my factor trees, prime numbers, all that stuff. For example, if I look at the square root of 4, I can break that down into 2 times 2. Now I know a lot of you know that the square root of 4 is already 2. I know that. I'm just kind of showing you the background of why it is. When I get to prime numbers, because 2 is a prime number, I'm going to look for pairs. I've got a pair of 2's. For every 2, 1 comes out of my radical sign, my little house. So because I have a pair of 2's, the square root of 4 is 2. For every pair, 1 comes out. If we look at the square root of 8, I can break that down into 4 times 2. Okay, now I'm going to keep going because 4 is not a prime number. I'm going to break 4 down into 2 times 2. And I don't have to mess with this 2 here because it's already prime. Alright, I've got all prime numbers, 2, 2, and 2, and I'm going to look for pairs. I've got a pair of 2's right there. So for every 2, 1 comes out. Alright, now I can't forget about this 2 back here. He didn't have a pair, so he's got to stay in the house. He doesn't have a friend, he's got to stay in the house by himself. So to simplify square root of 8, 1, 2 comes out, and whatever's left gets left in the house. Okay, always travel in pairs. If you don't have a pair, you can't go out. All right, square root of 12. If you would like to pause it here and try the square root of 12 on your own. All right, square root of 12, I can break that down into 3 times 4. Now, if you broke it down into 6 times 2, that's perfectly fine. You're going to end up with the same answer. 3 is prime, so 3 is done. 4 can be broken down into 2 and 2. Pair, for every 2, 1 comes out. Can't forget about my little 3 in there. He doesn't have a pair. So this simplified would be 2 root 3. All right, 2 root 32. There's something already on the outside, so I'm going to have to deal with that too. But for my prime factorization, I'm not worried about the 2 on the outside. I'm just looking at what's underneath the radical. So 32, I'm going to break that down into 8 times 4. 8 broken down into 4 times 2. 4 will get 2 times 2. Okay, those are all done. Now I've got to go back over here to the 4. 2 times 2, and now I'm done. So look for pairs. There's a pair there. There's a pair there. And 2 is all by itself. So I'm going to have 2 2's come out. 1 there, 1 there. So I've got a 2 and a 2 out. And my poor little 2 here is going to get left in the house. So when I bring 2 of them out, and I have a 2 already there. Okay, that's the one that is original in my problem. I'm going to multiply all of this. Anything that comes out gets multiplied. It also gets multiplied to what's already out there. So 2 times 2 times 2 would be 8 root 2. All right, square root of 45. I'm going to break that down into 9 times 5. And I can break 9 down into 3 and 3. Now I'm done. I've got all my prime numbers. So I got a pair of 3's. So 1 3 comes out. So my answer is 3 root 5. All right, square root of 60. 12 times 5. 5 is already prime, so I'm going to leave it alone. 12, I'm going to do 6 and 2. If you did 3 and 4, that's fine. 6, I'm going to do 3 and 2 again. All right, now this time I'm going to have to look elsewhere for pairs. I've got a 2 here and a 2 there. All right, so 1 2 comes out. Now I'm left with a 3 and a 5. Because neither one of them have pairs, they both have to stay back underneath my house. So I'm going to multiply them. 3 times 5 is 15. So 15 stays on the inside. And 1 2 comes out. So square root of 60 can be simplified to 2 root 15. All right, page 11. All right, we looked at those because we have to be able to do that process for these imaginary ones. Because all of these have negatives. So because I can't just slap this in my calculator, I have to be able to know that old school process. All right, while you're on this page, we're going to go ahead and mark through these two. We're not going to worry about those today. All right, when I look at something like the square root of negative 81, I know that that negative means an I is going to come out. Because I can rewrite that as the square root of negative 1 times the square root of 81. Okay, if I multiply those, it's going to give me that square root of negative 81. So the square root of 1 we figured out was I. So now I'm going to have to simplify the square root of 81. The square root of 81 is 9. I can break it down. 9 times 9, which would be 3 times 3. Pair, pair. 1 comes out, other one comes out. 3 times 3 is 9. So my answer to square root of negative 81 is 9i. Because I came out here, I'm going to multiply everything else that comes out by it. Alright, if you would like to try square root of negative 60 on your own, pause the video here. Alright, negative 60. We can think of it as negative square root of 1 times the square root of 60. This we know is I, and we're going to break down 60. We're going to do 12 and 5, 6 and 2, 3 and 2. There's a pair. So 1, 2 comes out to go along with my I, so 2I. Then I'm left with a 3 and a 5. 3 times 5 is 15. 15 stays in my house. No problem. Alright, the last example, square root of negative 9/16 is a little bit different. 9 and 16 are perfect squares. So my negative comes out with my I. Then I'm going to look at 9 and 16. By this point, you should kind of be picking up on what we're doing. You should know that the square root of 81 is 9. That just explained why. If I look at 9/16, the same process works. I know the square root of 9 is 3. I know the square root of 16 is 4. So both of those numbers are going to come out. I'm just going to leave them as a fraction. So what I mean is if I put this in my calculator, 3/4 is going to come out. Okay? But I can't forget about that negative, which means I need to put an I by it. Once you remember to take out that I, I'm okay with you punching the rest of this in a calculator. You have to remember to take out the I first, though. Alright. For practice, I want you to try those 3 first, so pause it here, try those top 3, then try the bottom 4. Alright. I's going to come out. Then I'm going to punch the square root of 72 in my calculator. When I do that, I get 6 root 2. I cannot forget about my I. So my answer is 6I root 2. Negative square root of negative 52, I is coming out. Square root of 52 is 2 root 13. So I'm going to have 2I root 13. And because of the I can't simplify that anymore. I can't punch the little STD button in and give me a pretty decimal. Alright, last one. Square root of negative 18. I comes out. The square root of 18 is 3 root 2. So I and 3, I'm going to put those together, so 3I root 2. Alright, second part. What is the value of the following? I to the 84, so I'm going to take 84 and divide it by 4. Remember these, I can't use my calculator on because I need my remainder. So 4 into 8 can go twice. So minus 8 is 0, and I'll bring down 4. 4 can go into 4 one times, so I don't have a remainder. So when I don't have a remainder, my answer is 1. Sorry. Answer is 1. Alright, I'm going to divide 50 by 4. 4 can go into 5 one time. 1 left over, bring down 10. 4 can go into 10 two times. 2 times 4 is 8. Leaves me with 2. So I have a remainder of 2. If I look back at my i's, when we were doing I squared, I to the cube, whatever, I'm looking at I squared. Remainder tells me the exponent I want to look at. So I squared we simplified down into negative 1. Alright, I to the 78th. 78 divided by 4. 4 can go into 7 one time. 7 minus 4 is 3. Bring down my 8. 4 times 9 is 36. That leaves me a remainder of 2. So again, I'm looking at I squared. So I to the 78th is negative 1. Alright, last one. I to the 31st. 31 divided by 4. 4 can't go into 3. 4 can go into 31 7 times. 4 times 7 is 28. 31 minus 28 is 3. So I have a remainder of 3, which means I want to look at I cubed. And I cubed, we found out, negative